Today we'll be finding the sum from 1 to infinity of 1 divided by 2 to the k times k squared. And we will start by proving an identity. And it's going to be the dilogarithm of x plus the dilogarithm of 1 minus x. And we'll use the integral definition of the dilogarithm. So this will be negative the integral from 0 to x, the natural log of 1 minus t over t dt, and then minus the integral from 0 to 1 minus x of the natural log of 1 minus t divided by t dt. And from here we'll make a substitution on the second integral. So we're going to let t equal 1 minus s. So that means that t1 will be 1 and t2 will be 1 minus x, which is 1 minus 1 plus x, which is equal to x. And solving for t, we have t minus 1 is negative s, so that means that s equals 1 minus t, and dt equals negative ds. So we're going to have negative the integral from 0 to x, the natural log of 1 minus t over t dt, and then minus the integral from 1 to x, the natural log of s divided by 1 minus s, and we're going to have a negative ds. But these negatives end up canceling, and s is just a dummy variable, so we're going to go back in terms of t. So now we have negative the integral from 0 to x, the natural log of 1 minus t over t dt, and then we have plus the integral from 1 to x, the natural log of t over 1 minus t dt. And from here we'll use integration by parts. So we're going to let u equal the natural log of t, but that means that du is 1 over t dt, dv equals 1 over 1 minus t, and integrating that we'll have negative the natural log of 1 minus t. So we're going to have negative the integral from 0 to x, natural log 1 minus t over t dt, and we'll have plus negative the natural log of 1 minus t times the natural log of t from 1 to x. We'll have negative the integral from 1 to x of negative the natural log of 1 minus t divided by t dt. These negatives end up canceling, and now we have negative the integral from 0 to x, the natural log of 1 minus t over t dt, plus the integral from 1 to x, natural log of 1 minus t over t dt. And then we're going to have a plus negative the natural log of 1 minus x times the natural log of x, then plus the limit as t approaches 1 of the natural log of 1 minus t times the natural log of t, but this limit just ends up being 0. And then from here we're going to have negative the integral from 0 to x, the natural log of 1 minus t over t, and I'm going to introduce a negative sign, but by doing so we're going to flip the bounds of integration. So we have the natural log of 1 minus t over t dt, and then we're having leftover negative the natural log of 1 minus x times the natural log of x. But by flipping the bounds of integration, we're now integrating from 0 to 1. So now we're going to have negative the integral from 0 to 1 of the natural log of 1 minus t divided by t dt minus the natural log of 1 minus x times the natural log of x. But this integral, the negative the integral from 0 to 1, the natural log of 1 minus t over t dt, This is just the dilogarithm evaluated at 1. And we'll recall that the dilogarithm of x is the sum from 1 to infinity x to the k over k squared. So that means that the dilogarithm of 1 is the sum from 1 to infinity of 1 over k squared, which is known to be pi squared over 6. So that means we've shown that the dilogarithm of x plus the dilogarithm of 1 minus x, this is equal to pi squared over 6 minus the natural log of 1 minus x times the natural log of x. So now that we've shown this identity, all that's left is to let x equal 1/2. So by doing so, we have the dilogarithm of 1/2 plus the dilogarithm of 1 minus 1/2. This is equal to pi squared over 6 minus the natural log of 1 minus 1/2 times the natural log of 1/2. But 1 minus 1/2 is 1/2. So we're going to have twice the dilogarithm of 1/2 is equal to pi squared over 6 minus the natural log of 1/2 times the natural log of 1/2. So we have twice the dilogarithm of 1/2 is pi squared over 6 minus the natural log of 1/2 can be rewritten as negative log 2 and then times negative log 2. But these negatives end up canceling. So we have twice the dilogarithm of 1/2. This is equal to pi squared over 6. We have a minus the squared logarithm of 2. So now dividing both sides by 2, we see that the dilogarithm of 1/2 is equal to pi squared over 12 minus 1/2 the squared logarithm of 2. But by the definition of the dilogarithm, we're going to have the sum from 1 to infinity of 1/2 to the k over k squared, which is the sum we're looking for, the sum from 1 to infinity of 1 divided by 2 to the k times k squared. So now we could say that therefore the sum from 1 to infinity 1 divided by 2 to the k times k squared is equal to pi squared over 12 minus 1/2 times the squared logarithm of 2. So that is the final result. Thank you very much for watching.